Welcome to a video on arithmetic sequences. We're going to make this the simplest video on arithmetic sequences that you have ever seen. So first off, before we dive too far into what arithmetic sequences are, let's talk about what a sequence is. A sequence is a function from the whole numbers to the real numbers. Consequently, the graph of a sequence consists of discrete points instead of a curve. So keep in mind, we all know what a function is. Input goes in, output comes out. But a sequence, only whole numbers can go in. That's counting numbers, 1, 2, 3, 4, 5, 6, 7. We don't plug in 0, we don't plug in decimals, we don't plug in negatives, we only plug in positive whole numbers. Now, what can come out? Well, anything. Any real number could come out, but only whole numbers can go in. All right, a sequence can be represented as a list of real numbers, and each value can be identified by its term number. So consider the following sequence: 3, 10, 17, 24, 31, 38. Well, we would say that the first term would be 3, so maybe put a little 1 there, or sometimes we'll call a sub 1, so the first term of the sequence. 10 is the second term, so that's a sub 2. 17 is the third term, that's a sub 3. A sub 4, a sub 5, a sub 6. You get the idea. So again, remember, a sequence is a function. So for example, whatever this function is, when we plug 3, well, excuse me, not 3. When we plug 1 into the function, we get 3. So 1, a whole number goes in, the outcome is 3. When we plug in 2, we get 10. When we plug in 3, we get 17. You get the idea. So what goes in? The number, the whole number, 1, then 2, then 3, then 4, then 5. And what comes out is the actual value of the term. So the term number is the first term, the second term, the third term, what have you, and out comes out the outcome. Now, the nth term, right, so think about what we just did, right? The first term you find by plugging in 1. The second term you find by plugging in 2. The third term you find by plugging in 3. So the nth term would be whatever term you want. So maybe I want to find the 57th term. All right, well, how do I find the 57th term? Well, you figure out what the function is. You plug in 57, you figure out what that term is. It's that simple, right? So the nth term is basically the function, the actual mechanical machine function that is producing these terms. Like, what is it that's taking 1 and turning it into 3? What's making 2 into 10? What's making 3 into 17? That's the function, right? Well, if I figure out what that function is, I could take 57, plug it into the function, and I'll get the 57th term. So part of the battle with working with sequences is finding what that function is that's actually taking the whole numbers and creating your term. Here's a couple examples of these types of functions. So this first one is a pretty basic function, right? Now notice we could use the function notation, or we could use a sub n, meaning any term. So for example, if I want to find the first term, that would be f of 1, or just plugging in 1, a sub 1, the first term, plug in 1, 7 times 1 is 7, minus 4 is 3. Oh my gosh, it's that easy. How do I find the second term? Well, that's plugging 2 into the function, or I'm going to get the second term, a sub 2, plug in 2, 7 times 2 is 14, 14 minus 4 is 10. There you go. All right, here's another example, a little bit more complicated. It's got some multiplication, some addition, and a division. But again, same basic idea. How do I find the first term? Plug in 1. 2 times 1 is 2 in the numerator. 1 plus 1 is 2 in the denominator. So I'm going to get 1 as my overall value. But again, the cool thing about this is you can find any term you want. So let's just say I want to find the 30th term. All right, that's easy. All I got to do is plug in 30. 2 times 30 is 60. I keep messing that up, boy. 30 plus 1, the denominator is 31. Boom, there is my answer, 60 over 31. So notice in this example, a whole number, 31 in, and a real number, this is going to be a rational value, some type of decimal, I guess, you could leave it as a fraction. But again, the only thing that can go into these sequential functions is a whole number. And let's look at this last one here. Again, how do I find the, I don't know, 5th term? Well, you plug in 5. It's that easy. So 2 to the 5th is 32. And 32 times 3, so let me show my work here. 2 to the 5th is 32. And then 3 times 32. Just make sure, obviously, you're following order of operations. And 3 times 32 is 96. So easy, easy, easy. Really cool. This is how you do it. All right, so what's an arithmetic sequence? Well, in an arithmetic sequence, it's just a very specific type of sequence where successive terms in arithmetic sequence have a common difference or a constant rate of change. So an arithmetic sequence is simply where the difference between the terms is the same, which makes it linear, right? An arithmetic sequence is a specific sequence where a linear pattern exists. A rate of change that doesn't change, right? That's what makes a function linear. Its rate of change stays the same. So to keep it really simple for you, arithmetic sequences are linear functions. Let's look at some examples. So this is one we actually saw a little bit earlier, 3, 10, 17, 24, 31, 38. So notice there's a common difference, up 7. 10, up 7, 17, up 7, up 7, up 7. So that's what we call the common difference. The common difference of 7. It's the value that we're going up by every single time. We're increasing by a constant rate. When you increase at a constant rate, you're a linear function. This one is going down 2, down 2, down 2, negative 1 minus 2, negative 3 minus 2, negative 5. So here my common difference is negative 2. I'm going down by the same value. I have a constant rate of change. That's a linear function. Here's another one. This time, yeah, I got some decimals. Don't be afraid of decimals here. Let me try to move that over a little bit for you. Don't be afraid of decimals. What's going on here? Let's see here. I'm obviously going up. So let's see here. The easiest way to find your common difference is just subtract two consecutive terms. So 8.1 minus 6.3 is up 1.8. Now let's check and see if that works. 9.9 minus 8.1 is, also up 1.8. So I'm going up 1.8 every time. So again, that is a constant rate of change. Up 1.8, up 1.8, up 1.8. So again, that's a linear function. Here's another one with fractions. Don't be afraid of fractions. So let's see here. What am I going up by? What am I going up by? But again, if you're like, I'm not sure, it's easy to see with whole numbers, like in our first example, but fractions might be a little bit trickier. Just take any two consecutive terms and subtract them. So 22 fifths minus 2 fifths is 4. Oh my gosh, believe it, I'm going up 4. Yeah, 4 is 20 fifths. So 2 fifths plus 20 fifths would be 22 fifths. And again, let's make sure that's working. Once again, 4 would be 20 fifths. 22 fifths plus 20 fifths would be 42 fifths. Yeah, so yes, I got fractions. It makes it a little bit harder to see, but once you look at the difference between any two consecutive terms, you realize that my common difference is 4. I'm simply going up 4. All right, now, we know now what an arithmetic sequence is. It's a linear sequence, okay? So how do we find that nth term? Remember, what is that nth term? That nth term is just the function. It's the actual formula that is finding any term we want. So here is how you find the formula for the nth term of an arithmetic sequence only. All right, so first we have a sub n. Remember now, a sub n is just a fancy way of saying the function, right? That's just the function. If you want to find the 30th term, plug in 30. Want to find the first term, plug in 1. Want to find the 19th term, plug in 19. All right, so here's how easy it is. It's a sub k plus the common difference, right? The common difference is what we are going up by or down by at a constant rate, times n minus k. Now the question here is what's k? Because sometimes that confuses students. K is simply the kth term of the sequence. So you could actually build an arithmetic sequence formula with any term you want. Let me demonstrate that for you. So again, this formula is a little bit tricky. Write it down. That's the formula for the nth term of an arithmetic sequence. And if you're a little confused how it works, I am about to show you. But just a couple things to keep in mind. D is the common difference. What is it that you are constantly changing by? That's your D value. N stays N. Like it's always going to be an N, right? It's just like the X in a function. You need a variable in your function. Linear functions have a variable that's N. But the A sub K and the K, those are going to be actual values. I'm going to show you how easy it is to work with those. All right, so here is a arithmetic sequence that we saw earlier, and it's pretty obvious that we're adding 7 repeatedly. So once you recognize that, you first recognize that it's an arithmetic sequence, then you realize that your common difference is 7. Okay, that's awesome. So now I'm going to build my formula, a formula to find any term. All right, I'm going to write down the formula, then we'll actually go ahead and use it. Whoop, that's a plus sign right there. And then it's times n minus k. Okay, watch how easy it is to use this formula. It's so easy. All right, all you have to do is pick a term. Any term you want to use. Doesn't matter. I'm going to use the fourth term. So the fourth term is 24. That's the term I'm going to use. All right, so here we go. A formula to find any term is, all right, I'm using 4 for k. You could use anything you want for k. It does not matter. I'm going to use 4. I'm just trying to show you it doesn't matter. So what is the fourth term? Well, that's what this is. A sub k is the fourth term. The fourth term is 24. Plus the common difference is 7 times n minus what was the term? What was k again? Oh yeah, I said k was 4. So again, I'm picking a term. I picked the fourth term, which is 24. The term value goes right here. That's a sub k. The term number goes right here for k. And then you just simplify. So 24 plus order of operations, that's 7n minus 28. And then I'm going to combine my like terms. 24 minus 28 is negative 4. There is my formula to find any term I want. But I just want to show you that it doesn't matter what you pick for k. You could pick anything you want for k. Now, I will say this, just being honest. A lot of people pick 1. Why? Well, it's the first term. The first term is clearly 3, so it just makes the problem a little bit easier. Working with the number 1 is kind of simple. So again, the formula to find any term I want is, okay, what is the kth term? Oh, the kth term I chose is 3, plus the common difference of 7 times n minus 1, because I was using 1. Again, I really want to emphasize the 1 is the term, and the 3 is the term value, just like I did over here. 4 was the term, 24 was its term value. But check this out. Even though I'm using a different term, I'm going to get the same answer. Let me just prove that to you. So distribute first, 7n minus 7, combine like terms. Oh my gosh, I still get 7n minus 4. Doesn't matter which term you use. Pretty cool. All right, let's check it out with this one right here. Once again, this time we're going down 2, down 2, down 2. So you first have to recognize that you are an arithmetic sequence, and the common difference is negative 2. And then I'm going to go ahead and use my formula. Any term I want to find is the kth term plus the common difference times n minus k. Sorry for my messy handwriting. And again, pick whatever term you want. This time I'm going to use the second term. All right, so I'm going to use a k value of 2, and I know that the second term is 3. All right, here I go. All right, the kth value is 3 plus the common difference of negative 2 times n minus 2. Again, k is the term value that I'm using. I'm using the second term, and the value of that term is 3. Alrighty then, just distribute here. That's going to be a negative 2n and a positive 4. Combine like terms, I get negative 2n plus 7. That's it. And again, I always tell kids, like, just practice, make sure it works, right? So for example, 1, 2, 3, 4, 5, the fifth term is negative 3. Let's just plug in 5 and make sure it works. Negative 2 times 5 plus 7. Negative 2 plus 5 is negative 10. Negative 10 plus 3 is negative 3. Or negative 10 plus 7, excuse me, is negative 3. So it just goes to show that the fifth term is negative 3, meaning the formula worked. The cool thing is once you have the formula, you can find any term you want. So if you want to find the 30th term, all you got to do is plug in 30. Negative 2 times 30 minus 7. That's going to be negative 60 minus 7. The 30th term is negative 67. How easy. All right, here's that one with decimals as well. Once again, how do with decimals, sometimes a little bit hard to see what that term value is, or what the actual difference is. So if you're thinking, well, I wonder if this is arithmetic, just subtract any 2 consecutive terms. You need to get the same number. So 8.1 minus 6.3 is 1.8. 9.9 minus 8.1 is 1.8. 11.7 minus 9.9 is 1.8. So clearly my common difference is 1.8. I'm adding 1.8 every time. Now again, same thing I mentioned a little bit earlier, a lot of students will always pick the first term. It's just a little bit easier to work with the number 1, and I have absolutely no problem with that. So how do I find the formula for any term I want? Well, I'm just going to start off with 6.3. That was the term value that I was looking at, plus the common difference, and n minus 1. Really important that you understand that this k value is the term for this term value. So the first term is 6.3. So just make sure that you are not using, like, don't use the second term in 6.3. You got to use the first term in 6.3. Why? Because the first term is 6.3. Then after that, all you have to do is clean it up a little bit. So distribute 1.8 times n is 1.8n. 1.8 times negative 1 is negative 1.8. Then we're going to go ahead and combine our like terms. The 6.3 minus the 1.8 is 4.5. So 1.8 plus 4, or 1.8n, excuse me, plus 4.5. Oh boy, okay, that's messy. 1.8n plus 4.5. There is a formula to find any term I want. Basically, this is a function with an n in it, but again, it's a sequence, so you can only plug in whole numbers. Now, earlier I mentioned as well that the graph of sequences, because you can only plug in whole numbers, it's a graph made up of distinct, discrete points. So notice that when you're working with a sequence, again, you're only allowed to plug in whole numbers. You're not even allowed to plug in negatives or decimals or fractions. So I'm plugging in 1, 2, 3, 4, 5, 6. I'm not allowed to plug in anything in between 1 and 2 because those are all decimals. So that's why you only get points. You don't actually connect these because you can't. You could plug in 1, you get 10. You plug in 2, you get 15. You plug in 3, you get 20. So what I'm doing, I'm going up 5, up 5, up 5, 10, and then 15, then 20. So my common difference is clearly 5. So let's create a formula for any term I want. Well, once again, all we have to do is pick any term. I'm going to pick the fifth term. The fifth term is 30. So the term value is 5. The term is 5. The value is 30. So 30 goes here, plus the common difference of 5 times n minus 5. Once again, I can't emphasize enough that this is the term number and this is the term value for that number. And then all you got to do is clean this bad boy up, and we get 30 plus 5n minus 25, and combine like terms, and we get 5n plus 5. It's that simple. All right, here's another one that's going down. Once again, we see that each term can only be a whole number. So there's the output for 1, looks like 6.5. Output for 2, looks like 5. Output for 3, looks like 3.5. So let's see here. What is my common difference? Well, I was 6.5, and then I dropped to 5, and then I dropped to 3.5. So it looks like my common difference is down, so negative 1.5. All right, how do I find that formula for any term? Well, use any value you want. I'm going to go with the classic first term. The first term, a sub 1, equals 6.5. So here I go. Boy, my handwriting is, this computer thing's not working well. 6.5 is the term value plus the common difference of negative 1.5 times n minus 1. 1 is the term number that I was looking at. And I'm just going to clean this up. 6.5 minus 1.5n plus 1.5. And adding my like terms, 6.5 and 1.5 is 8. So I get negative 1.5n plus 8. There's my formula to find any term I want. Very, very, very easy. All right, so here's the last idea. I really want to emphasize the idea that arithmetic and linear are the same thing. So similar to arithmetic sequences of the form I just taught you, a sub k plus the common difference times n minus k. Now this is based on a known difference d in a kth term. So again, think about what you need to build an arithmetic sequence. You need to know what the constant rate of change is. That's the constant difference d. And you need to know any term and its value. You only need one. Right? Well, that should actually kind of sound familiar. Like, go back to thinking about lines. And we would, in the past, we'd say, what do you need to build a line? You need the slope. Well, that's just a fancy way of saying rate of change. So realistically, your d and your m are exactly the same thing. And then you need a single point. That single point is any point. xi, comma, yi. And I just means any point, just any individual point. Well, it's the same thing here, right? D and m are the constant rate of change, and k and a sub k, that's just a point. That's my input k, and the output is that kth term. So what I'm trying to explain to you right now is basically building an arithmetic sequence formula is no different than building an linear formula. I mean, pretty cool, right? Okay, So arithmetic sequences and linear functions have the property that they can be determined by two distinct sequence or function values. The only difference is the domain. Remember, in an arithmetic sequence, you can only plug in whole numbers, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, whereas a linear function, you could plug in anything, negatives, positive, fractions, decimals, anything you want. But again, arithmetic sequences are the same thing as linear, the only difference being the domain. So let's look at this last idea here and just make sure we connect all the dots. All right, if I'm telling you that these are linear functions or an arithmetic sequence, right? It's the same thing. So the idea is that we have 5, 8 and 15, 12, input 5, output 8, input 15, output 12, and I could write that a separate way, right? Just plug in 5, you get 8. That means the fifth term equals 8. Plug in 15, the 15th term is 12, right? It's the same thing. It's no difference than a linear function. And if I said to you, how do you find the formula of a linear function? You'd say, well, I got 2 points. I need to find my slope first. So the slope is going to be subtracting the y's on top, 12 minus 8. Subtract the x on the bottom, 15 minus 5. 12 minus 8 is 4. 15 minus 5 is 5. So 15 minus 5 is not 5. 15 minus 5 is 10. And of course, that's going to reduce to 2/5. So there is my common difference, what I'm going up by every single time. So that's the same thing, called M, called D. It doesn't matter, right? And then the other thing I need is 1 point. I don't need 2 points. I just need 1 point. So I'm just going to pick this one right here. Now, in linear terms, we learned about point slope formula. So we'd say y minus the 8, that's the y value, equals the slope of 2/5 times x minus the x value of 5. And then, of course, we'd add that 8 over, and we would have the 8 plus 2/5 times x minus 5. Well, listen, this should look very familiar. This is the arithmetic formula that I just taught you. To find any term you want, you need a term value and its input. So 8 is the term value, plus the common difference of 2/5, and then x minus the term value. Well, actually, in a sequence we use n, but it doesn't even matter, right? You could use anything you want. So we have n minus 5. So once again, right, 5 is the value of the term, 5 is the term number, 8 is the value of the term. Well, that's no different than 5 being the input, 8 being the output. It's the exact same thing. All you have to do at the end is just obviously clean it up, distribute the 2/5, combine like terms. You could do all that. That's pretty easy stuff. So again, arithmetic sequences, you're going up or down at a constant rate, which makes it linear, because that's what linear functions are. And through the formula, you could build that function, right? You can build the function you want to find any term you want. It's a pretty easy formula, and it's the same as a linear form that we've been learning. The only difference is we're not using x's and y's, but I guess you could, right? It's just inputs and outputs. 5's my input, 8's my output. It's no different whether you want to call it the fifth value is 8 or plug in 5 and get 8. It's all the same thing. All right, hopefully you learned a lot about arithmetic sequences and how to create a formula for an arithmetic sequence.